Today, I'll show you how to use a signal meter. A signal meter is an essential tool when setting up a cell phone amplifier. It can help you identify the direction for the source of the cell signal and get the signal strengths for all carriers on voice and data, neither of which are possible using a cell phone. I'll walk you through a scenario and show you how to take a signal reading at a job site. If you're unfamiliar with the functions of a signal meter, check out this video here. When you get to a job site, you want to assess the signal for all carriers. Each carrier uses different channels within each frequency range, LTE, cellular, PCS, and AWS, for different uses. The FCC divides up cellular frequency into bands or channels, and each carrier is allotted certain channels to operate on. Basically, LTE, 700 MHz, and AWS, 2100 MHz, are primarily used for 4G data, with some exceptions for voice over LTE. Cellular and PCS, or 800 and 1900 MHz, are exclusively voice and 3G data for all carriers. When taking cell signal strength readings, you want to take your readings in the locations where the donor antenna will be mounted. The goal is to determine how much signal will be available for the amplifier, so accurate location reading is critical. The best way to get an overall picture of the signal strength at a site is to put your signal meter into channel power mode. Press the power or multifunction button and hold for a few seconds to turn the signal meter on. If your screen doesn't look like this, then you're not in channel power mode. Hold the multifunction button again for a few seconds to enter the menu. Press the select button to navigate to channel power, then press enter. At the top of your screen, you'll see the frequency you are reading, either LTE, cellular, PCS, or AWS. Below this, you'll see the signal strength here as a negative number, as well as a bar ranging from -110 to -40 along the bottom. The channel or band is displayed here. For each frequency, cycle through each channel by pressing the navigation buttons. Stay on each channel for 30 seconds to allow the meter to update. Do the same process on each frequency. Press the multifunction button to change frequencies, then cycle through all bands and log the data using our handy chart. Once you have all the data logged, now you have a good understanding of the cell signal level at the job site. If the majority of your readings are better than -75 dB, then you've got a good strong signal to work with. If most of your readings are less than -75 dB, then you'll want to visit the FCC Spectrum Dashboard website. The FCC divides up cellular frequency into bands or channels, and each carrier is allotted certain channels to operate on. Finding out which channels each carrier uses will help you understand which carriers are experiencing problems at a site, and you can adjust your setup accordingly to fix these issues. This chart shows the major cell carriers and which channels they are using. You can download this chart for your reference at the link in the description. We've got a link to the FCC Spectrum Dashboard in the description below, as well as in our support center. Use the map or enter your state and county manually in the boxes below the map. You'll then see all the various carriers in that area and the bands and channels each is using. You can also apply various filters on the left of the screen to narrow down your results even more. For example, here you see that AT&T at this location is using band 12 in the 700 MHz band and channel B in the PCS band. We know which band they're using by noting the frequency ranges used on the FCC website and cross-referencing that with a chart I referenced earlier, which shows which frequency ranges fall under each band. Knowing this information is important as it allows you to compare signal meter readings to determine the signal strength of each carrier signal at a site. From there, you can adjust your amplifier and system design for the site's specific needs. You can also use a signal meter as a director to locate the cell tower or fine-tune your donor antenna. Using the included antenna, you can stand in a location and circle around 360 degrees to find the direction of strongest signal. You can also attach the signal meter to the end of a cable coming from the donor antenna to get an even more accurate reading of the incoming signal level to the amplifier. This is very useful, especially in a weak signal environment. Doing this allows you to make adjustments to the positioning of the donor antenna and see the results instantaneously, allowing you to find the best signal strength possible coming into the amp. From here, you have your basis for calculating your coverage area that you can expect for each carrier, and can choose the placement of your donor antenna and the orientation accordingly. Before I move on, I want to mention one issue that you may run into. The signal meter will measure all RF energy in the area. It won't differentiate between cell signal and any RF noise that you might be experiencing. Many pieces of equipment like AC units, transformers, and AC outlets can emit RF noise. If strong enough, the signal meter will pick this noise up and display it on screen, leading you to believe that you have a strong cellular signal. If you notice that you have a strong incoming signal level across multiple channels on the signal meter at a location, but are unable to place a call, or the signal on your phone shows up weak, then this is most likely what is happening. Thanks for watching. If you've got any questions, let us know. We'd be happy to answer those. And check out one of our other videos for more great tips like this. We release new videos every week, so don't forget to subscribe. We'll see you next time.